the previous sections, we now have in place really all of the important time value of money relationships. These relationships prove to be very flexible, and what we're going to look at now are some special considerations in time value analysis. The first of these we're going to look at, well, we'll just make a short list here of these items, is compounding periods that are other than annual. Everything we've done up to now assumes that payments come on an annual basis and that compounding occurs annually. That need not be the case. We could compound more often than that, semi-annually, quarterly, monthly. For example, a credit card bill, interest is assessed every month, and then the next month the interest is assessed on that, so there's compounding in that environment that occurs on a monthly basis. So we want to understand how we would go about making adjustments for compounding periods that aren't annual periods. Another thing we're going to look at is, and we've actually seen this already, or we will, if you've worked some of the problems already, you might have seen this, situations where we have a pattern of payments where the payment amounts aren't the same, so it's not an annuity, but we have non-repeating patterns, or at least not perfectly repeating patterns. Where we should look at deferred annuities. Deferred annuities are annuities that don't start at time 1. What happens if you have an annuity that begins at time 5 or time 4? How do we go about valuing that annuity at time 0? The annuity tables that we use, the annuity formula that you would find in the footnotes of the text, find the value of an annuity at the beginning of a period where the first payment comes at the end of the period. So if we had an annuity that starts at time 4, that's actually, we can use the tables to find the value at time 3, but that doesn't give us the value at time 0. So we'll talk about that. And finally, the deferred annuity can be a part of just a more complex arrangement where we have multiple stages, where there's an annuity at the end, but before that we have other payments that we've received. And how do we go about finding the present value of all those? We'll start with multiple compounding periods. So in certain contractual agreements, you might have semi-annual, quarterly, or monthly compounding periods. And the adjustment for this is relatively simple. The number of periods that we have, instead of being the number of years, if, for example, we have 3 years that are compounded monthly, we're going to multiply the number of years times the number of months to get 36 months. So in 36, if you use monthly compounding, in 3 years, you'll have 36 months. So this is just the number of periods in terms of months, if we're using monthly compounding, that you have over the life of the item that you wish to compound over. Likewise, or sort of in reverse, if we have to multiply the number of years by the number of periods, we have to divide the interest rate by the number of periods that we have in each year. And the reason for that is the interest rate that we're given is an annual rate. So the I that we're now going to determine is determined by dividing the quoted annual interest rate by the number of compounding periods. If it were monthly, it would be 12. So let's take a look at a couple of cases. Determine the future value of $1,000 invested after 5 years at 8% annual interest, but it's compounded semi-annually. So semi-annually compounding means that even though we've got 5 periods, okay, we've got 5 periods, we actually have 10 compounding periods. And the interest rate of 8% is annual. Well, that's not an appropriate rate for a 6-month rate. The 6-month rate will use half of that amount, or 4%. So N in this case will be equal to the 5 years times 2, and I will be equal to the annual interest rate divided by 2. So in this case, we're being asked to find the future value. We take the present value of $1,000, which comes from here, multiply it by the future value interest factor, which is in table or Appendix A, which is the appropriate interest factor for n equals 10 and I equals 4. If you look in the table, you'll find that value of 1.48. Let's consider a second case. Determine the present value. So this was a future value problem. Now we're looking at a present value problem. Determine the present value of 20 quarterly payments. Quarterly means there are 4 each year. Okay. Quarterly payments of $2,000 each to be received over the next 5 years, where I is equal to 8%. So we have $2,000 payments. We have 20 of those. That's an annuity. Okay, so we've got 20 payments. We could draw those out all the way out to 20. We're going to get $2,000 every period for 20 of them. One of the keys here is, and I'll change colors to remember that because we have quarterly payments, this annual interest rate of 8%, we have to divide 8% by 4. So we're going to use 2%, a 2% discount rate. Okay, so n is now equal to 20 because we have 20 payments. I is equal to 2%. And this is just an annuity. We find the present value of an annuity equal to the annuity times the present value interest factor for an annuity, where n is equal to 2, n is equal to 20 and I is equal to 2. That's table 9.4 or Appendix D. And I see a typographical error here. This A actually is the 2,000, so let's just scratch that out. This A is 2,000, and we multiply that 2,000 times 16.351, which comes from the table, the present value interest factor of an annuity table, and the present value is 32,702.